An even function is a function that has symmetry respect to the y-axis. In other words, it has a vertical line symmetry. And an odd function is another way to describe a function with origin symmetry. Even functions have vertical line symmetry, and odd functions have origin symmetry. So the way you can find an even function that it has symmetry over the y-axis is that you're going to replace all of the x's with a negative x. And if you can replace all of the x's with a negative x, and it still looks like the original function, all the signs are the same, then it is going to have y-axis symmetry, and therefore it is an even function. If you replace the x with a negative x and all of the signs are different, then it's going to be an odd function, which means it has origin symmetry. So let's show you an example of these. This one says determine whether each function is even, odd, or neither. Confirm algebraically. If the function is odd or even, describe the symmetry. So looking at part A definitely does not have vertical line symmetry. You cannot fold it over a vertical line and have it map onto itself. But it does look like it could potentially have origin symmetry. It might be able to rotate 180 degrees about the origin and look the same way as it does. So I say potentially has origin symmetry because it might be just off just a little bit microscopically that it's really not origin symmetry. So the way we can confirm if it has origin symmetry, meaning that it's an odd function, is that we are going to replace the x in this function with negative x. So we're going to replace all of the x's with negative x, which means I would have negative x to the third power minus 4 times negative x. And if when I compute this, all of the signs are different, then it is going to have origin symmetry, meaning that it is an odd function. So when I take negative x to the third power, negative x to the third power is just negative x to the third. Negative 4 times negative x is positive 4x. So notice that the signs are different from the original function. It's a negative x to the third power, and then in the original function it was positive x to the third power. And in the new function I've got positive 4x, and in the original function it was a negative 4x. So since all of the signs different, I'll just write that in there, all signs different, this is going to have origin symmetry, which means it is an odd function. The second one, part B, g of x equals 2x to the fourth minus 6x squared. This one definitely does not have origin symmetry, because if you flip that w around upside down, it's not going to be a w anymore, it's going to be an m. But it could potentially have y-axis symmetry. And to determine if it has y-axis symmetry, that means it's going to be potentially an even function. So we're going to do the same process. We're going to find f of negative x, and we're going to replace all of the values with a negative x, all of the variables with a negative x. So that would give me 2 times negative x to the fourth power minus 6 times negative x to the second power. So 2 times negative x to the fourth power. What is negative x to the fourth power? I'm going to write this over on the side here. If I take negative x times itself 4 times, what happens is when I multiply the first two negative x's times each other, since it's a negative times a negative, that's going to be a positive result. So this is positive x squared. And if I multiply these two negative x's times each other, that's also going to be x squared. And then when I multiply x squared times x squared, they're both positive, which means the result's going to be positive. That would be x to the fourth. So negative x to the fourth is actually the same as a positive x to the fourth. And then I would have minus 6 times what is negative x squared. And you can see we've actually done negative x squared already. When you take a negative x times a negative x, you actually get positive x squared. So notice on this one, the signs are the same as the original function. We come up with the exact same original function. And when that occurs, that means it does have y-axis symmetry, so it is an even function with y-axis symmetry. And then part C. Part C, I don't think it's going to have y-axis symmetry. Doesn't look like you can fold it over the y-axis, but it does look like it's got origin symmetry. I think you can flip that upside down, and it does look like it's going to have origin symmetry. So we've got the function there. We're going to verify this algebraically by figuring out what f of negative x is. So I'm going to replace all of the variables with negative x. So that's going to be negative x to the third power plus 0.25 times negative x to the second power minus 3 times negative x. So negative x to the third power, that's going to be negative x to the third, plus, when we take negative x to the second power, remember that does equal positive x to the second power, so this is 0.25 x squared. And then negative 3 times negative x, since they're both negative, that's going to be a positive 3x. And what we're looking for is we want all of the signs to be the same as the original function, which means it is an even function with y-axis symmetry, or we want all of the signs to be different, and it's an odd function with origin symmetry. And you can actually see it's not either one of them. It starts out looking like the negative, the signs are different because notice we have a negative x cubed and a positive x cubed. But this sign, this positive in front of the 0.25x squared is the same. So one of the signs was the same, but one of them was different. And we need all of them the same or all of them the different to have one of those two special types of symmetry, and we don't. So this one actually has no symmetry. Even though it looks like it has origin symmetry and we can flip it around upside down, it doesn't. It's probably off just by a little bit. It's just microscopically off. And I think if we look at the graph a little bit closer, we can see that this hump right here would have to flip over and land on this hump. And it's just not the same size. The hump on the top is a little bit bigger than the hump on the bottom, so it actually does not have origin symmetry.